principle of heat exchanger. So first we'll look at the function of the heat exchanger. So the main function of the heat exchanger is to transfer the fluid between two fluids without having them mix. So this will be the basic diagram of the schematic diagram of the heat exchanger. As can be seen here, the one fluid will come from here and then exit from this exit, and then there will be another fluid from the tube. So let's say that the fluid inside the tube is the hotter one, and the fluid coming from the first inlet is the cold one. So when this fluid moves, it will through the conduction and the convection, the heat will transfer from this hot fluid to the cold fluid that flowing from here, and at the end of the hot fluid will become cool, and then the cold fluid become hot. So as for the type of flows, there are two major type of flows in the heat exchanger. The first one will be parallel flow. As can be seen from this diagram, the hotter fluid and the colder fluid move in the same direction. This is called the parallel flow. As for the counter flow, the flow inside the tube will move to the right, and then the flow from the outer will move in the opposite direction of the fluid.
This is our FILA table that we constructed to identify the possible causes of the problem, which is crack in heat exchanger of the steam boiler. The main problem that we found is that firstly is old heat exchanger and metal fatigue, lack of air movement inside the heat exchanger, oversized furnace, metal corrosion, poor airflow, and stress and flexing of the metal.
This is the first method to investigate the causes of failure. Common uses of the Ishikawa diagram are product design and quality defect prevention to identify potential factors causing an overall effect. Each cause or reason for imperfection is a source of variation. Causes are usually grouped into major categories to identify these sources of variation. The categories typically include people, machine, material, measurement, and environment.
The factors that cause the crack of heat exchanger are environment, connection, oversized furnace, people, deposition, and process. The environmental factor is because of the weather, higher temperature surrounding, oxygen and water, which can cause the rust for heat exchanger. The connection usually is not tightened up and the gaskets fail that can cause water and steam leak. For the oversized furnace, can cause the poor airflow and filter clog and also overheating. Then the people's factor means the attitude at work. Training is not provided for new worker and also unexperienced employee. In people's factor also include the poor maintenance, which are preventive and daily. For the deposition factor, poor external treatment can resulting in poor boiler feed water quality, poor chemical control, and also inadequate blowdown control. The last factor is the process. Because of the process can resulting in thermal stress of the structure. Boiler freeze can cause the structure crack and overheating of boiler, and pump failure can resulting in metal fatigue.
Okay, another method we use to for identification is we use fault tree analysis. Okay, fault tree analysis is a deductive analysis approach for resolving an undesired event into its causes. Okay, this is achieved by a backward-looking analysis. Looking backward, at the causes of a given event to exhaustively identify the cause of the failure. Okay. This for three analysis is to identify weakness in a system, to prioritize the contributors to failure, and quantify the failure probability. Okay, this 6 is the basic systemic diagram that we use in the fault tree analysis. This square is for top event, diamond shape, undeviated event, and this circle one for basic event. And this tree is the basic gate that we use in fault tree analysis. This is for OR gate, AND gate, and transfer gate. Okay. OR gate is used when the above output event occurs if either of the input lower level event occurs, and the AND gate is used by the indicating that the above output event occurs if all of the input lower level event occurs, and the transfer gate is used to transfer to or from another part of the fault tree. For fault tree analysis, the main event is crack in heat exchanger in boiler. With that, we divided the possibility factors that contribute to the crack is number 1 is failures in tube bundle, lifespan limit, and failure in body. For failure in tube bundle, there are 3 factors that contribute to the failures, such as biological growth, accumulation solid particle, and leakage. And for failure in body, there are 2 factors, structural deficiency and inaccurate specification. For structural deficiency, there are another two factors that contribute, corrosion and metal fatigue, while for inaccurate specification, only one that contribute to the factors is blast furnace.
This is the basic graph of FMEA analysis, which is input of the main problem, failure mode, effect, severity, causes, occurrence, current control, detection, and RPN, which is therefore the list of priority number. For the input is the place that we put the problem that we face. Failure mode is the failure that causing the problem. The effect is the effect of the failure mode, and severity is how much the severity of the failure, and the higher the rating of the severity, the higher the severity of the failure. And the causes is the causes that cause the failure mode to happen, and the occurrence is the rating that how frequent the failure are. The higher the rating, the more frequent that failure happen. And the current control is how we can control the failure mode, and the detection is the rating on how easier the failure mode can be detected. The higher the rating of the detection, the harder the detection of the failure mode. And the RPN, which is stand for risk priority number, is the product of severity times occurrence and times detection. The higher the RPN number, the more we should emphasize on. This is the FMEA analysis. The first column for the process step input is the maintenance of failed steam boiler, and the potential failure mode that occur is crack on the heat exchanger steam boiler, and the potential failure effect of the problem is steam boiler cannot function properly and might not operating at all. The severity of the failure mode is rated by 9, and the potential causes can be divided into 5 point, which is old heat exchanger, metal fatigue, metal corrosion, poor airflow, stress and flexing of the metal. The occurrence of the problem is rated by 7, 5, 8, 3 and 4, which is the higher the rating occurrence, the more frequent the problem happen, and there is current control that have been taken to overcome the potential failure, which is research on durability of the heat exchanger, research on effect and remedies of overheating in boiler, research on preventing corrosion, check the flow rate of airflow to avoid overworks for furnace, and research on material selection for metal of heat exchanger. For the detection column, the higher the detection rate, which is 1 to 10, the harder the problem can be detected. For the RPN, which is stand for risk priority number, the severity will be times with the occurrence and detection, and then we will get the value of RPN for each potential causes, and from the value of RPN we can indicate what action can be recommended to reduce the problem that we face.
The last method we are going to use to identify the problem is step diagram. Step diagram is like a chronological chart which lists the event according to the time they happen. So this is the basic layout of the step diagram. So here is the time, it will be the months or year or date depending on the time span of the problem. So this is the actors, the people or equipment which are related to the problem we are investigating. So here is the case study. This will be the main problem. So event 1 is the first event that occurs caused by the first actor at the earliest time frame. So the consequent events will be related to the first event. So this first event causes the second event, and the second event causes the third event. After that, we will finally have our failure here. From this chart, we can trace back to the earliest point where the problem originated. From there, we can identify the root cause of the problem. So the actors may be the people involved in the problem, and then the equipments or the apparatus that are related to the problem. In the main problem for the heat exchanger is the crack in the heat exchanger tube. So for the actors, the manufacturer is the first actor, and because first problem is the internal structural defect during the manufacturing, which is the main cause for this problem. So the second actor will be the engineer who missed monthly inspection of the heat exchanger. Because of his lack of preventive maintenance activity, the crack is left undetected. So the next actor is the connection. In the connection, there will be in the gasket rail, the section will not be tightened up because there is a problem within the structure. So the next actor will be the tube, because in the tube we can see the rupture in the tube of heat exchanger. There will be loss of efficiency in the heat transfer of the heat exchanger. The last will be the operator, because he need to shut down the boiler operation because of the lack of efficiency from the heat exchanger. Okay, the next method we are going to use to identify the root cause for the problem is causes and effect chart. So this chart is almost similar to the why question method. So we got one answer, and then we ask why, and then we go to the next answer. So then again we ask why, and then we go to another. So we go deeper to the main problem until we can't get any more deeper. So in this causes and effect chart, the uppermost part will be the effect of the main problem we are facing. The physical part is the physical damage or the problem we see in the equipment. So the human part will be the human causes the effect. Human activity that cause the physical damage in the equipment. So the systematic will be what are the causes that cause human to act in such way. So the latent cause is the like almost like the main cause that causing all this above to act in the manner. So usually the latent will be like associated with the ideology of the management system. For the causes and effect chart, the uppermost part is the effect. For the effect is the problem, and the problem is the heat exchanger of the boiler is cracked. So if we see the physical cause, there we see the visible crack on the surface of the heat exchanger. It may be caused by the corrosion or other factors. So the human cause which caused the corrosion or crack in the heat exchanger tube is lack of experience of the operator, lack of training for the people who operate the heat exchanger, and the poor attitude of worker who did not emphasize on the preventive maintenance. And systematic cause that causes these problems are no proper introduction for new workers on how to operate the heat exchanger. The next will be no license in operating boiler for the boilerman, and the poor attitude will be the result of no performance standard set by the company to assess the performance of the worker. All this will be caused by the latent cause that we identify as the poor emphasis of the company on the maintenance regime. So this will cause all the upper said part to act in a certain way.
One of the causes that is contributed by material aspect on the boiler heat exchanger crack is due to the incompatible material use. Due to the material incompatibility, corrosion would occur. It is important to know the type of material used for the heat exchanger of the boiler in order to prevent the failure due to the corrosion. If we know the material used, even the material used was incompatible or is a low quality one, earlier prevention can be made, such as treatment of material. There are many prevention methods can be made in material treatment, such as surface coating, alloying, and etc. Corrosion that occur on the boiler of the heat exchanger will produce crack in the joint and also on the surface of the heat exchanger. At once, leaking will occur. Due to the leaking caused by crack, the efficiency of the heat exchanger will decrease, thus the heating process of the boiler cannot be done properly, such as the required heat cannot be produced. Besides that, if crack that will cause leaking on the heat exchanger occur, there will be higher need of power consumption for the boiler in order to meet the required heat.
One of the most visible defects of the heat exchanger is crack in the tube. This may be caused by corrosion. Corrosion is the degradation of metal due to chemical reaction with the environment. Place where the heat exchanger located plays an important role in the lifespan of the heat exchanger. Damp environment will accelerate the rate of corrosion in the metal. Damp air contains high level of moisture content. Water droplets in air reacts with metal in heat exchanger tube and cause corrosion. Corrosion eventually causes leak in the tube which carries the fluid. Other than corrosion, pitting also causes damage to the heat exchanger as seen in tube 2 and 3. It is caused by electrochemical potential set up by differences in the concentration of oxygen within and outside of the pit. Pitting corrosion occurs during shutdown when there is no fluid flow and environment is more suitable for the buildup of the concentration cells.
Labor is the one causes of failure. Firstly, lack of communication can create uncertainty that leads to stress and conflict for every employee. For instance, one worker may not have an experience at all about maintenance and he may be waiting for a colleague or from experienced supervision to assist him or supervise during he do the maintenance or running the heat exchanger. If the colleague or experienced supervision does not respond and could resulting in conflict between them. The employee might not do the maintenance or running the machine correctly. Sometimes it is also because of the lack of training and attitude of every employee. The company might need to provide the training for each their new or unexperienced labor about the skill of maintenance and to get the license to do the maintenance for heat exchanger.
The first factor that contributes to process is metal or erosion. Fluid visiting in excess of the manufacturer recommendation on either the shell or tube side of the heat exchanger will likely cause erosion damage, as well metal wears from the tubing surfaces. If any corrosion is already present on the exchanger, the erosion is accelerated, exposing the underlying metal to further attack without a protective coating. The second one is vibration. Excessive environmental vibration from equipment including air compressor, refrigeration machine or other motors can cause tube failures that form as a result of fatigue stress cracks and or erosion where the tube make contact with the wafers. The third one is thermal fatigue. Tube, predominantly in the U-bend section, can fail as a result of fatigue from accumulated stresses related to constant thermal cycling. This problem is significantly aggravated as the temperature difference across the U-bend increase. Temperature difference cause the tube flexing, which subsequently produce a stress load that until the material tensile strength was exceeded and therefore cracked. And the last one is freeze up. Freeze up as a result of the operator failing to provide thermal protection from the elements, improper drainage during a seasonal shutdown, malfunction of a thermal protection system or heater, or inadequate antifreeze solution.
The equipment factor of heat exchanger could be one of the causes of failure, such as failure in body, the lifespan limit, and failure in the tube bundle. Failure in body of heat exchanger is because of the structural deficiency from corrosion and metal fatigue. The structural deficiency of heat exchanger body happens due to poor material from an inaccurate specification of material that being used by the manufacturer, such as large furnace. If this corrosion or metal fatigue of heat exchanger is not being repaired, it may cause the major problem for owner. Then, failure in tube bundle mainly because of the biological growth, accumulation solid particle and leakage at joint of heat exchanger. This failure of tube bundle can be avoided if the proper maintenance schedule and scope is followed and it is assigned to the skilled worker that have license and experience in that case.
For decision making process, we have constructed the decision matrix table to identify the root cause for crack in heat exchanger. The qualities of this decision that we listed are corrosion, metal fatigue, erosion, lack of maintenance, and substandard material. And the option we have is material, process, environment, labor, and equipment. And we found that material has the highest score, 22, and we choose that as a root cause of the crack in heat exchanger pipe.